Welcome to part 2 of the video. Let's start off by looking at some more examples. For each of the following examples, determine the individuals in the study, any variables, the type of variable, i.e. categorical or quantitative, and the role of the variable, explanatory or response, and determine the type of study, observational or experimental. So example 1. In order to determine if there is any relationship between gender and academic major among Longwood students, a survey is conducted. So who are the individuals? That would be the Longwood students. And there should be 2 variables. So we have gender and academic major. Both of those, gender and academic major, would be categorical variables. But which one is explanatory and which one is response? So we could say that we're trying to determine if gender explains one's choice in academic major. So the gender would be the explanatory variable, and the choice of major would be the response variable. And we're conducting a survey to collect this data. This survey, we're not imposing anything on the students, we're just collecting information from them. So this type of study is an observational study. Let's look at another. Athletes are divided into 2 groups, and each group is given a different training regimen. The athletes are then tested to see how fast they can run. So why don't you pause the video and see if you can answer these questions on your own. And now you can check your answer against mine. So the individuals here are the athletes, and the variables are the training regimen and how fast they can run. And we're trying to see if the training regimen has any effect on how fast they can run. So the training regimen is the explanatory variable, and what training regimen they got is categorical. How fast they run is the outcome. It's the response variable. And that time is a measurable number, so it is a quantitative variable. This type of study is a bit different. We are assigning a training regimen to these athletes, so we're controlling the explanatory variable. So this type of study is an experimental study, and the control is who gets what training regimen. Now we need to talk about bias. Any good statistical study, observational or experimental, should be designed to avoid bias. We say a statistical study is biased if it systematically favors certain outcomes. So suppose you wish to estimate the average height of undergraduate female Longwood students. Since you work for the coach, to collect your data, you go to the women's basketball team locker room and measure the players. Who are the individuals and what are the variables? So the individuals that we're interested in here are the undergraduate female Longwood students. We want to answer a question about all of these students. The variables are the height. We want to estimate the average height. So why does going into the women's basketball team locker room introduce bias into our results? Well, traditionally, basketball players are of a much higher average height than the normal student would be. So going into the women's locker room isn't a representative sample to answer questions about the population of all female Longwood students. So this is biased. Is it observational or experimental? Well, we just observed their heights. We didn't impose a treatment on them, so this would be an observational study. So we try to avoid bias by avoiding poor sampling designs. Two classic examples of poor sampling design involve a convenience sample. So our basketball example was a convenience sample. We worked for the coach, so it was convenient to walk in and observe the women's basketball team. Another common convenience sample would be something like a shopping mall interview. Yes, you are interviewing people at the shopping mall, but you're ignoring everyone who was not at the shopping mall. Voluntary response samples are also poor sampling designs. If you've looked at Rate My Professor, someone who would go to Rate My Professor and write their opinion either typically loved the professor or hated the professor. It's very rare that you get someone who is just lukewarm about a professor leaving an opinion on something like ratemyprofessors.com. Same thing with internet polls in general. Internet polls such as CNN's Quick Vote. People who respond to things like that are typically very opinionated and are at one of those two extremes. It very rarely gets someone who's more moderate or in the middle of an opinion. So how do we avoid those types of bias? For observational studies, we want to select individuals from the population so that the sample is representative of the population. And for experimental studies, we want to assign individuals in the study to treatments so that the treatment groups are essentially the same in all respects, except for which treatment they're receiving. So to achieve this in either case, to avoid bias, we want to use randomization. That is the way that we avoid bias in either case. So sampling design describes exactly how to choose a sample from a population. A good sampling design should enable the researcher to extract a sample from the population using a methodology that does not induce bias. The resulting sample should be representative of the population. So a common form of choosing your sample is using a simple random sample. We can abbreviate that with SRS. Here we will use N to denote the number of individuals in the sample. In a simple random sample of size N, individuals are chosen from the population in such a way that every set of N individuals has an equal chance to be the sample actually selected. This is oftentimes done via a computer. We can also do it with a random number table. So when I see you on Wednesday of next week, we'll play around with both of these things using your calculator and using a table of values to choose simple random samples in class. So thank you for watching, and I'll see you Wednesday.